What you see here is a velocity time graph. Now it's kind of similar to speed time graph, but the fundamental difference between velocity and speed. Velocity is a speed, but in a particular direction. So for example, I'm traveling roughly 2 centimeters a second to the right of the screen. So my velocity would be 2 centimeters per second in that direction to the right. We can call it east. Whereas speed is not really aware of direction. Speed is just a value. Like you can say 2 centimeters per second, but there's no direction, right? So that's the fundamental difference between velocity and speed. What I'm going to do now is calculate the acceleration between 0 and 45 seconds, between here and here. Now there's a formula for that, or you could just, what you can do, because you've got a graph here, you can just work at the gradient from here to here. Just work at the gradient of this graph. That's going to be rise over run, or if you like, height of this triangle divided by the base of this triangle. All right. Now the height of this triangle, it's 10, because it reaches a maximum velocity of 10 meters per second. So the height is 10, and obviously the base here is 45. So all you're going to do to work at the gradient is the height of the triangle divided by the base of the triangle, or if you like, rise over run. That will be 10 divided by 45. That's your acceleration. Now the units for acceleration is meters per second per second. It's written like this. Or if you like, meters per second per second. I'll talk about this units in a moment. If I just do the next part, calculate the acceleration between 95 and 150 seconds. It's talking about this bit here, this portion here. I need to work at the gradient of this bit there, the gradient. So I need to know the height. Well, the height I already know, it's 10. It's the same as, well, the same as this. And the base of that triangle, well, the difference between 150 and 95 is 55. So it's rise over run. 10 divided by 55. One thing you need to be aware of is that this portion here, it's a negative gradient because it's going downhill, so it's negative. It's a deceleration. So when you get a negative acceleration, that means it's decelerating, slowing down. I'm going to look into this a little bit more deeper now. Right, there is a formula that you can use to work at acceleration. It's given as v minus u divided by t gives you acceleration, where v stands for final velocity, u for initial velocity, the starting velocity, and time it takes to get from u, a velocity of u, to a final velocity of v. Right, I'm going to put that into context using this, the numbers over here in the graph. I'm going to work at the acceleration from here to here. Remember, we can work that out using the by finding the gradient of that line. Using the numbers now, v, that v is the final velocity. So it starts at 0, the initial velocity, and it reaches a final velocity of 10. Right. Remember, we're only considering the journey between 0 and 45 seconds. I don't care what happens afterwards, right? I'm not bothered about that at the moment. My story begins at 0 meters per second and finishes at 10 meters per second. My story, everything happens between 0 and 45 seconds, right, for this calculation. So the final velocity, it reaches 10, so v is 10. The initial velocity, it starts at 0 meters per second. And the time it takes to get from 0 meters per second to 10 meters per second is obviously 45 seconds. You can see that there. That gives me the acceleration. So that'll be 10 over 45. As we've seen earlier on, the acceleration is 10 over 45. 10 divided by 45. If you want that as a decimal, I can do that for you. It's 0.2 recurring. The units are going to be, its acceleration, it's meters per second per second. I will explain that towards the end of the video. Right, for the final portion, this bit here, I'm going to use the same formula again. Right, this time my story begins at 95 seconds and finishes at 150. I don't care what happens before that or after that. I'm only concerned with what happens between 95 and 150 seconds. Obviously the time difference here, 150 take away 95, that's 55 seconds. So that will be my value of t. Right, so let's substitute the numbers then. V, the final velocity, well, it starts at 10 meters per second and it goes down, it slows down until it becomes 0 meters per second. So the final velocity is 0 and the initial velocity starts, it's 10. Divided by 55 seconds. It took 55 seconds to get from 10 meters per second down to 0 meters per second for this part of the journey. So our acceleration is going to be minus a negative 10 over 55. I can show that as a decimal now. I get negative 0.18. The 18 part is recurring. That's acceleration, that's meters per second. Right now, I'm going to explain to you why it's meters per second. If you think about the formula, just do it here. Right, the top part there, the numerator, all of that represents velocity. That's final velocity, that's initial velocity. Velocity is taking velocity, it still gives you velocity. So the unit on the top, the numerator, is meters per second. Don't forget that that is a division symbol, right? Meters divided by second. Meters is distance, seconds is time, that's distance divided by time. Distance divided by time is speed, or velocity if you like. All right, and on the denominator, you've got just time, seconds in seconds. So let's just rewrite that. That's meters per second on the numerator. That's a division symbol, meters divided by second. Remember that there, meters per second, that's meters divided by seconds. That there is a division. And we've got, on the denominator, we've got seconds. Right, I want to do keep, change, flip to this. So I'm going to change the last one into a fraction. There you go, that's still a fraction. Seconds is the same as second divided by 1. It's the same thing. Just like 10 is the same as 10 over 1. Keep, change, flip. So we're keeping this one. Change the division to times and flip the last one. So what does that give us now? Meters times 1, m times 1 is m, and s times s is s squared. Right, so that's meters per second per second. I have written that over here and here. Right, that is meters divided by second squared, meters divided by second squared, or you can just pronounce it as meters per second per second. Right, the other way to write this is as like this. If you know the rules of indices, you can change that to -2. For example, if you've got 1 over x, that's the same as x to the power of -1. If you've got 1 over x squared, that's the same as x to the power of -2. Right, that's part of rules of indices. If you've got, for example, 1 over s squared, that's the same as s to the power of -2. But if you had the meter at the top, if you had the meters, the value m at the top, you put an m here as well.